So here we're going to look at modeling linear data. So we'll be given some information that will fit usually a line or be close to fitting a line. Or I could say a line would be close to fitting the data. So just a couple of terms here: bivariate data, bi meaning two, variate meaning variables. So you have data with two variables or two things that could change. A scatter plot is a graph of ordered pairs on the coordinate plane that represent this data. And then a trend line is a line drawn to best represent the set of data. Trend line can be used to predict results. Now, we're going to be talking about lines here. But there are lots of different things we could talk about. It doesn't have to be a line. It could be some sort of curve that we might have that the data is close to. And we'll get to that more as we go throughout Algebra 2. So let's go ahead and look at an example. This says, draw and determine the equation of the trend line that models the 10K data. Then predict the number of training miles required to complete the race in 30 minutes. And so it has this table here. Training miles 100. The run time was 70 minutes. 200 training miles, so ran more, the time dropped to 67 minutes. 300, it dropped to 53. 400, it actually went to 55. 544 and 647. And so all of these data points are graphed here on this graph. And so it says draw and determine the equation of a trend line. Well, a trend line is going to be a line that fits this data. Notice it's going to be, this data is going down from left to right. By the way, remember this, these are our training miles, and then this is the time it takes for a 10K. So those are the axes there. And so we can graph a line here. You kind of want it to follow the data. So if I were to graph this line twice, it might be a little bit different, but here's the one I have here. This one's almost there. There's a couple or a few below the line. There's a few above the line. So there's my estimation of the trend line. So we have the line, and we want to determine the equation. Well, we have the graph of a line here, and we want to write the equation. So in order to write the equation, we need the slope and we need the y-intercept. Now this looks like the y-intercept is 80. We just sketched this line, so it might not always look exact. So what we're going to do is we're going to use the point slope form to find this. So y equals, sorry, not y equals, y minus y sub 1 equals m times x minus x sub 1. So we need a point, and we need the slope. Well, what we're going to do is we're going to look at our line here. We're going to try to find a good slope. Well, here we have a couple helpful points. So here, the line crosses through the point 360, and then down here, it crosses through the point 640. So we have these 2 points here. We have 360 and 640. And by having those 2 points, we can find the slope. So slope is y sub 1 minus y sub 2 over x sub 1 minus x sub 2, which gives us 20 over negative 300, reduced by 10, and then 2 goes into both of these, so we get a slope of negative 1/15, which makes sense. That's negative because it's going down from left to right. Now notice these are spaced. This is 100. So our spacing isn't the same on our x-axis as that is on the y-axis. So we can't go by the looks as if it looks like negative 1/15. So now we have y minus, and we can use either one of these points. So let's just use our first one here, y minus 60, our y value, equals the slope, which we just found was negative 1/15, x minus 300. We'll distribute, so we got y minus 60 equals negative 1/15 x. Negative 1/15 times 3, negative 300 is going to be positive. And 15 goes into 320 times. You could calculate that out or write that out if you needed to. So we have that. We distributed, now we add 60 to both sides. And as I mentioned before, it looks like the y-intercept is 80. So we add 60 to both sides, we get 80. So there is the equation of the trend line. So we drew the line, we determined the equation. It's right here. Then predict the number of training miles required to complete the race in 30 minutes. So we want to know how much, what would we have to do for this to hit 30 minutes here. So it looks like we just have, using our trend line, it would have to be out here somewhere. So we want our minutes to be 700, which is our our x value. I'm sorry, 30 minutes, which is our y value. So we're going to go ahead and put 30 in for y. And we can subtract 80 from both sides. I didn't leave myself much room here. And we'll put that answer up here. So we have negative 50 equals negative 1/15 x. We want to solve for x, multiply both sides by negative 15. So the reciprocal of that, negative 15. And we get x is equal to, negative times a negative is positive. 15 times 5 is 75, so 15 times 50 is 750. So according to the trend line, the training, 750 miles of training should get to a 30-minute 10K. There's two things that we can do with the data points. This is interpolation and extrapolation. Extrapolation, sorry about that. Interpolation is the process of making predictions within the data points. Extrapolation is the process of making predictions outside the data points. So let me just point this out to you. So if we wanted to determine if you did 350 miles of training, what would your time probably be? That's within our data points. Our data points go from 100 miles of training up to 600 miles of training. So interpolation would be trying to predict something within here. Extrapolation is trying to determine something outside these data points, which is what we did here. Which is probably more accurate? Well, interpolation is more accurate usually, or can be, because you have the data points around and you can draw your line to fit them. Also, there could be a change here. So right now, yes, this looks like a line, but if this line continued, it might look like, well, if you train 2,000 miles, you would get 0 minutes for your 10K, which obviously is impossible. So sometimes for extrapolation, it changes as you get further out here. There are a couple ways to determine how well or how closely a line fits to the data, and this is called linear correlation. And then we have this correlation coefficient, which is R, and it's just a numerical way to describe the degree of which the two variables are related. R will always be between -1 and 1. Positive correlation, so if you have a positive number, anything above 0 but less than 1 means it's a positive slope and a positive R value, means the two quantities increase or decrease together. So as x goes up, y goes up. As x goes down, y goes down. So that's a positive correlation. And then a negative correlation is the opposite. It's an inverse relationship. So if x goes up, y goes down. And if y is going up, x is going down. So we have positive and negative. And then we're going to talk about the actual magnitude of these numbers, so how big they are. So now the closer the absolute value of r is to 1. So if we're getting close to 1 or getting close to -1, it's getting stronger correlation. If the absolute value of r equals 1, so if you actually have 1, if r equals 1 or if r equals -1, all the data points lie on the line. So if it was 1, all the data points would lie on a line that has a positive slope. If it was -1, all the data points would lie on a line that has a negative slope. Looking for strong correlation, you want to be 0.8 or higher. Weak correlation is less than 1/2. And then there's sometimes these outliers. Outliers are points that don't seem to fit the trend line. So maybe there was an error in calculating, or maybe there's just one that's really strange or different. Sometimes you ignore outliers, so that is a way to calculate or talk about the linear correlation. We use the correlation coefficient, which describes how closely the data points are clustered along the trend line. So here are some examples. Coefficient of determination, you also can take that r and square it, which will make it all positive, and this represents a percentage. So again, you're trying to get close to 1 to have a high, strong correlation. So let's take a look at these. This is a strong positive. It's strong because they're clustered together. Positive because it's going up from left to right. This really has little or no correlation. There's no line that fits here that all these are clustered closely to. Here we have a strong negative. Strong because they're clustered together closely. Negative, they're going down. As x's increase, the y's are decreasing. And then here's a weak positive, definitely going up left to right, but pretty spread out, and a weak negative. And that's trend lines.